Okay, good morning. Welcome to
Number 704.
FamilyMath704. So yesterday we were somehow the topic of a rocket going to Mars came up when we were talking. What was the reason for that?
I don't know.
You were just thinking about it?
Remember.
Okay. So we watched a video this morning about launching a satellite to Mars. Why don't you draw some pictures about what the issue is?
Well, the issue is that
Why is this hard?
Earth's orbit and Mars's orbit. Well, you can't launch just if Earth is here and Mars is here. You can't launch
What's
in a
the
straight
center
line.
circle?
This is the sun.
It's gonna be pretty warm today.
Alright, so I'll do the two orbits.
Okay.
So you can't launch like this because Earth and Mars are going to be moving, and Earth is moving at a faster speed than Mars.
Okay.
So the rocket will miss the planet entirely.
Okay. So if you tried to point the rocket at the planet.
You
And-
can't do it.
Okay. I got a kind of a fun little question for you. Here's the situation. The two planets are lined up like that, just on a perpendicular. Mars is moving slower than Earth. Earth is moving faster than Mars.
Yeah.
Okay. If you launch the rocket here, just point it right at the planet, just launch it and say go. It's gonna miss.
Yeah.
Right? Is it gonna go in front of Mars? In other words, is it gonna end up over here with Mars behind it, or is it gonna end up over here with Mars in front of it? What do you think?
I think it'll end up in front of Mars because Earth has a smaller orbit and is moving faster.
Okay.
And Mars has a larger orbit and is moving slower.
All right.
So when the rocket hits Mars, Earth is going to be here, and then Mars would be about here.
Okay. So where's the rocket gonna be then?
Well, actually, no, because the rocket doesn't care about Earth right now. The rocket is just going on this course.
All right.
So the rocket's actually going to be behind.
Behind both of them.
Okay. What do you think?
Well, yeah, so if you launch it in this position, when it gets there, Mars is going to be over here.
Okay.
And then Earth will be way over here, but it's just going to miss both.
Interesting. Okay, so something a little bit different than that is actually going to happen. We'll watch a video. So the rocket's going to have this motion from the Earth.
Yeah.
Yeah.
So it's going to actually not go.
But you aimed it at this point here.
Yeah. So it's, I guess, well, yeah, maybe it's tricky to see.
Yeah.
So the Earth is going to move a little bit. The rocket's going to have this. At the time you launch it, the Earth is sort of moving this way.
Mm-hmm.
So the rocket's going to acquire that speed too, just because of the Earth. It's like throwing a tennis ball out of a car.
The tennis ball keeps moving.
The tennis ball, or baseball might be a better example. The baseball gets some of that velocity, but I'm glad it's interesting to try to think about what happens. So what do you have to do to get this to
You
work
launch
correctly?
it when Mars is here and Earth is over here.
Okay, and what
So
happens?
that when it launches at this angle, and then Mars is going to be moving, but it catches up to Mars because Earth has greater speed.
Yeah.
And then then once you get to Mars, you have to worry about landing, but this is just to get to Mars.
Right. Landing is a completely different problem. You can certainly get to Mars. That seems like pretty complicated all by itself, but we can do it. All right, so I'm going to show you two interesting things. One sort of a nice visual, and one just something you need to learn about planets.
All right.
Okay.